a tremendous input. Not only that, there was a really a color imaging camera which took almost 3,000 shots before the prop touched down on the lunar surface. So this has enabled us to wet our hands in managing the orbital missions around the moon, and finally how to descend to the moon also. So that way I will say that this has been one of the fantastic achievements as well as the first attempt to go to the moon. In fact, next one please. This shows how the moon surface at close quarters looks like. You can see the crater is something like 500 meters in depth, and nearby hills almost similar order heights, and there is some ridges and so on. So this kind of images are being collected. Every time it makes one round of the moon in about 2 hours, it takes a set of pictures, and it, of course it goes on indexing while the moon is rotating. And we hope that in about a year's time, the entire lunar surface will be covered this process. So this is giving not only the three-dimensional image of the moon, but also it provides an opportunity to look at some of the features like the craters, and maybe it will throw ideas as to how the craters itself has originated and how the moon itself has evolved over time, and perhaps give an idea as to the element deposit which is there. Of course, when you talk about elements, two important elements people are, the scientific community is really thrilled about. One is to look for the helium-3, the best form of atomic fuel which can be there, and also if there are traces of water. If you know the water is there, it's going to really help us in trying to establish our colonies there, and also use it for various purposes, like even for decomposing and using as a fuel for interplanetary travel and so on. But so far there is no evidence of water on the moon, and if we find something, it's going to be very interesting and very challenging for the future community. Next one please. This shows another hilly region. It's unlike our hills, you know, it's all, there's no vegetation, no, because there's no water, there's no atmosphere, no oxygen and so on. Again, you know, you can see the type of the impacts, what is made by the meteors on the surface of the moon and how the surface is destroyed and so on. So while we are doing a lot of things technologically on the space, we look at the moon and beyond also. Well, to achieve this, we require a space transportation system. As Professor Rao has been mentioning, that we should shrink the cost of access to space, and truly we are committed to that. All started with launching a small sounding rocket from Tumba Equatorial Rocket Launching Station near Thiruvananthapuram, and from there we have come a long way. Today we have the PSLV and GSLV as our workhorse launchers. They can take the PSLV specifically tuned for medium class payloads which can go in the near Earth orbit, either polar orbit or inclined orbits, and the GSLV is specifically tuned for carrying spacecraft in the geotransfer orbit. So that way most of the requirements, the national needs, could be met by these two launchers. And of course, Arians has been our partner all these years. We have launched our heavy satellites from the Arian. Even last year we had the INSAT-4 launches, and 4G is almost getting ready to launch for next towards the end of the year, and so on. But ultimately we want to, not as a competitor, but maybe as a cooperative and a collaborating agency with the European space community to evolve the next generation launch that's called the GSLV Mark III. The looks are more or less similar. We are not copied Arian, but it's evolved by itself. Well, there's going to be a much less number of stages. So that way one can expect a much higher reliability, and since the number of stages are less and it is a more efficient form of transportation, and ultimately we are targeting something like 4 tons into geotransfer orbit compared to something like 2.5 tons in the current GSLV. This 4-ton class of payloads is really going to be useful and we believe that this is going to provide an opportunity for reducing the cost as well. Even now, the Indian launchers are less expensive compared to the European or American launchers. We have the price range is somewhere about 70 to 80% compared to the others, and that itself is cost effective. But while the GSLV Mark III comes into operation, we believe that the cost can halve to present level, and that's going to be a tremendous advantage for accessing the space. Next one, please. Well, this just talks about how we delivered 10 spacecraft at one shot to the low Earth orbit. And next one, please. Well, one of the technological challenges which you have undertaken recently was the development of indigenous cryogenic stage. This stage is proven, and that's getting ready for the flight sometime in the middle of this year. Next one. It is not only that we can take a spacecraft into orbit, but it can be brought back to ground safely as well. This has been demonstrated in our spacecraft recovery experiment, which was conducted in about 2 years back. Here, a 500 kilogram module containing 2 microgravity experiment was placed into the near Earth orbit. After about 10 days of its operation, on the 12th day, it has been brought down. And again, with the meticulous planning in the mission and implementation, we were able to make it impact on the ocean within about 15 kilometers. So this has been again a demonstration of the capability to bring back this object from space. As you know that as it re-enters, tremendous amount of heat is generated. That provides a real challenge for the thermal management. A special ceramic tiles have been developed for this purpose, and it has been proven in this flight. And finally, it was to our surprise that inside temperature has not gone beyond 50 degrees Celsius. What we expected was close to about 80 to 100 degrees. So that shows the efficacy of this thermal protection system, and the mission management, how we are done, is demonstrated by the accuracy with which it impacted. And later, with the flotation system and everything, it was just floating on the sea. Our Coast Guard went there and brought back the system. Next one, please. Always the thrust has been to indigenize the technologies and the products, and we are very happy to say that almost every aspect of the launch vehicle and the satellite technology, today we have got homegrown products, and we are happy to say that they are performing as well as what is available anywhere in the world. In terms of materials, we have the marine steel, we have got the titanium alloys, we have got the composites products, the propellant chemicals which are required for liquid and solid propulsion, and so on. And a host of chemicals which is required for spacecraft application also has been developed.